So I'm Michael Staib. I'm a GraphQL TC, so I'm working on the technical steering group at the GraphQL Foundation and developing there the actual GraphQL spec and other child specs. Today I want to talk about a new initiative which we call GraphQL Fusion. We have first showed that off at GraphQL Conf in San Francisco in September. And I'm going to walk you through this new approach to distributed GraphQL. So GraphQL Fusion is, since September, under the GraphQL Foundation, so it's an open standard. We are still working on the last bits of the specification and hope to finally publish the first bits of it, I think mid-December. Okay, let's start. I know there's always this one person that doesn't know what GraphQL is or has a wrong idea about it. So that is my 3-minute introduction to GraphQL, just the very quick one. And then we go quite deep into the idea of distributed GraphQL. So when GraphQL was released, then Facebook actually had quite a problem with their mobile application. And that is where GraphQL comes from. So what they discovered is that different clients have very different needs. I think that is obvious, but they discovered that back then in, let's say, 2008, 2009. So they reversed with GraphQL the concept of data fetching. Instead of the backend engineer describing what you can do with your API, they gave this power to the front-end engineer. This is our, you could say, hello world in GraphQL. It's a very simple GraphQL. It's a shorthand query, actually. And we are asking here for the currently signed-in user, and from that currently signed-in user, just for the name. So when we fire that to our backend, to our GraphQL backend, we get a response that closely aligns to this request. And that is actually the basic concept of GraphQL. This, you specify what data you need, and then the GraphQL server will fulfill this data need. And it almost looks like we're sending in an empty JSON graph and get back some data, so a filled up JSON graph. But it's not just about flat data structures, it's also about trees of data. So I can drill in. If my components change or my data requirements change, I can drill into my data structures and fetch more data. And as we expect, then we just get what we asked for. And that's the principle of GraphQL, if you will. But there's one more aspect that I want to mention here, and that is when we look at data trees, it's actually how we humans think about data, right? It's this relational approach to how we can dive into these things. And that means I cannot only just fetch things that are related to my current entity, I can also drill into connections to other entities. For instance, if you think about the Facebook use case, I can fetch the user information of the currently signed-in user, but also all the related stuff, like the friends, the news stories. But we can also see there's some repetition here. Like name last seen is declared multiple times. And maybe I even need that in different components. So that's where GraphQL, or the designers of GraphQL, actually introduced a construct which is called a fragment. It's our primitive for composition. And this allows us to specify data contracts in our client components. This fragment actually is a data contract for my UI components. And this allows me to co-locate my data requirements with my actual data usage. Like in this React component, we, for instance, have at the top our data requirement. And then down here, we just use this data. And as I compose now my components, I'm actually composing a GraphQL query without even noticing. Okay, as I said, 3-minute, just a very brief introduction to GraphQL. If you want to know more about the basics, like there are often basic talks. Okay, let's actually dive into distributed GraphQL. But let's reflect on the one fact I said here, like different clients have very different data requirements, right? And that is the thing where GraphQL was born with. That was the initial property. And the really best thing I think about GraphQL is not that you get the most efficient data fetching that you need for every client. It's actually this unified API schema. That means you are exposing your world, your business model, in a human understandable way, where you can drill into connections, explore what the API holds for you, and really reason about what the business model is about. And this is actually where, when Facebook introduced GraphQL to the public world, because they started with GraphQL internally in 2012, but in 2016, when they actually released the open source specification and the reference implementation, people would start and take this GraphQL server that Lee Byron back then implemented and just front their existing infrastructure. And that is opposed to where GraphQL actually comes from. So when Facebook implemented their first GraphQL server, they would front their business layer with a thin layer of GraphQL. So basically, they built a monolith. But when GraphQL came out, front-end engineers would take GraphQL and front their existing infrastructure, which typically at that time were just REST APIs, lots of REST APIs that were difficult to use and also difficult to understand. Or maybe you even had a microservice setup and you wanted to simplify it. You just put GraphQL in front end of it, and you suddenly have this human understandable data model or business layer that you can reason about that. And that made it so much easier for front-end engineers to use the data that the back-end engineers exposed. So when we talk about distributed GraphQL, we're actually talking about breaking this graph, this initial graph that we have here, into subgraphs. And that is kind of formalizing what these initial users of GraphQL, these initial front-end engineers, basically did. We are formalizing a way to have these microservices or these subgraphs and compose from them a single GraphQL gateway. But we don't do that actually just because we like microservices or whatever. It's to give our teams the ability to work in isolation. So when I think about why you should use distributed GraphQL or distribute your graphs, it's actually not because of scale. The scale needs are something that is technical. But what you really want to do is enable your teams to work in isolation on a single graph. And behind these subgraphs could be still microservices or whatever other technical complexity you need to have. But what you want to enable here is that, for instance, the account subgraph is managed fully by a single team that takes care of these microservices and the subgraph itself. And when they hit deploy, that composes all into the gateway, and we don't block each other's teams. And there are solutions out there for this particular problem. There's, for instance, Atlassian Natal, which was one of the first solutions we saw there. This is a proprietary technology, so it's not an open standard, but there is technology for that. There's also various implementations for schema stitching. There is something that is called GraphQL Mesh, which was built by the Guild. It's based on schema stitching, but a couple of iterations ahead. Or there's Apollo Federation, also not an open standard, very closed. And that means there's actually no open standard. And that, in consequence, is that you basically have a vendor lock-in. So if you choose any of these solutions, you have to go with everything what this vendor gives you. Like you have to take the tooling from that vendor, and you have to go with the services from this vendor. And that's where actually Chili Cream, that's my company, and the Guild came together back 1 year ago and said we have to change this situation and introduce an open standard around distributed GraphQL setups. And that's where GraphQL Fusion comes in, which, as I said, is now under the GraphQL Foundation and is an open source specification, which is licensed as an MIT MIT. So when we look at a thing like GraphQL Fusion or distributed GraphQL, we're actually looking at a couple of components. So what does make up a distributed GraphQL server? The first thing I said is something like schema composition, like merging these subgraphs into an overall gateway. There is an output of the schema composition. So after we merged our subgraphs, the outcome of that is the gateway configuration. So something that we can feed in our gateway to start this gateway, and this gateway now has this merged distributed graph on which we can execute queries. So there is something that executes, which we call a remote executor. On top of that, there's one more component, which is telemetry, because we need to figure out where something is wrong in our gateway. So let's start with some constraints we wanted to have when we started our journey here to distributed GraphQL or to an open source specification towards distributed GraphQL. One thing is we wanted to embrace GraphQL as it is. Like all the solutions I showed you before have tons of downsides because they are not embracing GraphQL as a full thing. They are trying to introduce subgraph protocols or weird directives or whatever. And what we wanted to do is really embrace GraphQL as it is. We wanted to allow any schema that is out there, whether it's a GitHub schema or whatever other schema you find and have lying around, to be a valid subgraph in such a distributed GraphQL setup. And we wanted to use patterns and best practices that are out there. Like, for instance, the relay pattern or others that are in GraphQL, for instance, the enterprise patterns. And that's where we should talk a bit about schema composition first and then dive into some code. These are almost all my slides. But let's focus in on the first component I set here. And that is the schema composition. So when we look at this setup, we're actually not focusing on the consumers here. We're focusing on the subgraphs. So when you talk about schema composition and how we can merge these graphs, we have to do some semantic analysis of the schema. And what we essentially did as a rule here is introduce that if you have two different types on a subgraph, on different subgraphs, like user maybe exists on account or user maybe exists on reviews, then these are semantically the same users. And when we talk about the merging algorithms here then we are talking about folding these two types from two subgraphs together. So when we look at these two types here, we can see that they have some overlaps, we call them, like ID and name. We have them on both subgraphs. We could take them as collisions, but Fusion takes them as overlaps. That means when we merge that, we check if the overlaps actually match type-wise, like ID has the same type, name has the same type, and the others don't exist on the other side. So we can merge this type into one GraphQL type. But there could also be collisions. Like I could have a type where I have maybe string on one side and ID on the other side, and then we would give you a proper error and tell you, okay, your two subgraphs don't match, we don't know how to merge that, and then you have to fix that. But there could also be collisions or type differences that could be merged, like this ID field here where we have a nullable ID type and a non-nullable ID type. This could be merged because we could check that and then say, okay, then the overall type will be nullable because we cannot guarantee the non-nullability of one of the subgraphs. I said overlaps. So we have these two fields here. These are overlaps. And these let our query engine actually make the execution of GraphQL queries much faster. I will show you that in the practical examples. And then we have certain fields that are only available on one or the other subgraphs. Let's actually have a look at some code. Let me just get rid of this guy here. Okay, so I have here a very small setup where we have a gateway. I will go through the gateway. It's actually very empty at the moment. So this is our GraphQL gateway server. This is a Fusion implementation that we did in our open source project. There are at the moment 2 prototype implementations, you could say. There's Hot Chocolate Fusion, it's from our open source project, and the new Mesh version from the Guild will also implement the GraphQL Fusion spec. Okay, so this gateway is very empty. It has nothing to it, but we have a couple of subgraphs here. For instance, I have the account subgraph, which is a node server. I can just dive into my index.json here, or index.js, and you can see this is a typical implementation. This uses GraphQL Yoga as a server here, and we have some random data for users here, and the schema overall focuses on user. So we have here like this user type, which has a name, display name, and birth date or whatever. So this is everything that is count related. So what we want to do is merge that first graph into our gateway. So before we can do that, we need to compose. As I said, there is something called a Schema Composition. And this is where we have some Fusion tooling, and we can compile at build time our GraphQL gateway. Why at build time and not at runtime? That is because we want to make sure when we deploy that we don't break the API for our clients. And the Fusion Composition tooling allows us to do that. So if we break, for instance, one of our clients, one of our consumers, if we break a field or change a field that some client is using, we get a compilation error. If we do something that would lead to the gateway not working anymore, we would get a build error. Okay, so the first thing I'm going to do here is actually composing. So I'm doing a Fusion compose. And I'm using here my gateway. So I say target this gateway. This is this directory here. And I want to compose first the accounts subgraph into it. The account subgraph is not running yet, but I can just compose because I have the schema information here, and you can see there's a change in the gateway. And I can actually start the gateway. And that's one of the aspects here. You never have to stop the Fusion gateway. It works with hot reloads, so as we get a new schema in or schema changes, it slowly phases out the old version and then phases in the new version. So my gateway is running here. I can go here to my gateway endpoint. And then I get here this IDE. That's our GraphQL IDE. It's called Banana Cake Pop. All our things are named like things on the Starbucks menu. And I can just open here a new tab. And then we can explore our GraphQL schema. For instance, I can look here at my query type and dive from there in, and I can see that I have here a user by ID, user by name, and a users field. And from there I can dive into my user type, right? And that is a one-to-one stitch. So we have everything that we have on our account subgraph here, and we can dive in from there. So I can dive in here. I could run that, and that doesn't work because I haven't started yet my subgraph. But my GraphQL gateway already would work, even if my other subgraphs are down. So let's start that. So I'm going here to my account subgraph. I'm just starting my node server here. And when I run that again, I now get the results from my subgraph. So that is actually not impressive because I just have a one-to-one stitch. But let's add some additional data. As I said, we are folding data from different subgraphs together. And that's what we're going to do. So we go to our composition tooling again. And this time, we're going to take this review subgraph, which sits here. This is a .NET server. Also doing GraphQL, I have a ton of data here, which adds to my users this reviews field. It adds reviews that I have about products, and I can compose that into my gateway. So we're going to use the Fusion Composition tooling again. So we say Fusion, then compose, and in this case, we take reviews. Okay, we composed that. Let's start actually reviews immediately. So .NET run. This comes up. So I'm just refreshing my gateway. I didn't have to restart it. And now I have a much richer schema, which now includes mutations, subscriptions. As I said, we embrace all GraphQL features. So we also have streaming events and whatever is there available. So I can now dive into my query type here, go to my user type, and suddenly I don't have just birthday and display name, but also this reviews field, which was folded into my user type. And that means I can now dive into my reviews here and fetch the reviews that this user has written. And if I execute that, you can see this user has no reviews. If I scroll a bit down, I can see here are a couple of users that made reviews. So now the surprising effect. I can look at the query planning process of my gateway by clicking here and say, actually, I want to enable query planning, and that will give me the query plan. And if I look at the query plan, you can see that we initially fetch data from the review subgraph, and then we compose the result. But there is no accounts graph in here. So we are not fetching the users from the accounts graph. Because what we discovered is that we have overlaps. We discovered that name is actually existing on both subgraphs. And we calculate, when we do a first time this request, what the least hops possible are to get the data that we need. So we just go to the review subgraph and get all the data from there. Only if there is data that we cannot get from the review subgraph, we will also include the account subgraph. You can see now I'm fetching data from the review subgraph. All the data I can get from the review subgraph, this is the biggest chunk of data I can get. I'm going to the to batch additional user informations in here. I can have a look at the data here actually, at the raw query plan. And you can see this is our original query. Then we are going to the review subgraph. We are getting all the data that we need. And then we are exporting here the user ID. We are collecting all the user IDs from the first service. And then we're going to batch that into the second service. So what is striking here? I haven't explained anything to the composition. I just said these are two GraphQL servers, figured out how that works together. So what the composition discovered is that I, on the second subgraph, actually implement the nodes pattern. That is a GraphQL enterprise pattern. And we're going to use that, in this case, to batch fetch the user entities here by feeding in this Fusion exports here, which we collected from the first subgraph. And this is super awesome because we have predictability in our query execution, and we can even optimize this query execution if we find something that doesn't work out. Okay, let's dive a bit deeper into that because we have a couple more subgraphs. For instance, we have here products. Let's get products in, and actually let me just start them all so we don't have to jump back and forth. .NET run, and I'm going back to the schema composition while they're starting up. And the next thing I want to compose in is actually the product subgraph. So I'm saying Fusion compose, then we're going to do the products subgraph here. And we can go immediately back here, refresh, and then you can see that we actually can dive into this reviews more and say, we also want the product. And from the product, we actually want the name. And this thing here comes now from another subgraph. You can see how the query planning gets more complex over time. And we are even optimizing for things that we can fetch in parallel. So we first collect all the user IDs and the product IDs, then we feed that into our other subgraphs and fetch these in parallel and compose from that the actual result. For the user, this is actually always very fast and always feels like a single service they are communicating with. Although behind that service are hidden all the complexities to scale well or to have different teams work in isolation on their problems. Okay, let me show you one more thing to that. And that's our last service, which I want to compose in. And this last service, let's do that. We're going to compose here the shipping subgraph in. And that will just work, but there is an issue with this thing. So I have now here the product, and I have this shipping subgraph, which has an algorithm to calculate the shipping estimate for my product. So I can go here to the delivery estimate and then ask what is the maximum time I have to wait to get that product. And this thing here, this delivery estimate, has some arguments. So I can ask, for instance, for the zip code, where I want to ship it to. So I can type in anything, it's just fake. And then I have two other things like size and weight. So this algorithm wants to know the size and weight from the product. This subgraph is isolated, so it just implements the raw algorithm to calculate that, and it needs like size, weight, and zip. That's the three things it needs. We actually have these on the product subgraph. We have a field dimension, which actually has the size and weight. So I don't want to actually feed these information in here. I actually want the subgraph, the shipping subgraph, to automatically fetch these data from one subgraph, feed it into itself, and then calculate it. So I want to establish requirements. While we didn't explain anything to our GraphQL Fusion Composition tooling at this point, we can if we have more complex things. Like in this case, I want to give just some metadata to express more complex situations. So to do that, I can just annotate my schema. And it doesn't matter which technology you have, you always can just add here a schema.extensions.graphql file. And then we can add some annotations. We do that by using the extend syntax from GraphQL. So we say extend product. And then we have here this delivery estimate field. And then we can say actually size and weight are things that we want to resolve implicitly. So we can add here a requirement. So I can say require the size by using the dimension field wherever this exists in my graph and just automatically feed it in. We can do the same thing with weight. And then we can recompose this thing. Go to our query here. Say we want to refetch that. And then we don't have to feed any arguments here anymore in. They are not even visible anymore because these are internal arguments that are just for the algorithm. So now I can just run that. And then we can look at our query planner, and we can see first we are going to fetch from reviews. Then we are exporting from reviews the fields product ID and user ID. These we're going to feed into the products and the account subgraph in parallel, fetching these data. And then we need the data from the product subgraph. You can see here it exports two information, which are weight and size, into the next subgraph. So the next subgraph needs the product ID, the size, the weight, and then we compose the result. And that means we get all the data like with the estimated delivery here in one query. The user doesn't see anything, and you can see like when the query plan is built. So the first request had the query plan overhead, but then we are fetching from 4 subgraph, but still 7 milliseconds. So the graph is very fast, and we'll figure out what the most efficient way is to fetch all the data that the user needs for his use case. Okay, one more thing. So this is all query, right? But there are also other operations in GraphQL. Mainly things like subscription. Subscription are real-time queries that I have. And in my example, I have here a real-time query to fetch the review. So whenever a review is written by a user, then I can query for this review in real time. So basically I say, every time the review is being created, I want to have this data for this review printed out here. So when I run this query, you can see it's waiting there, it's spinning there, because it's real time. It only will be executed whenever a review is being written. So I can go over here to a second window, actually. Let's take a separate browser, maybe here. Let's take this one. Okay. And here I already have a query, which is a mutation, where I say I want to create a review. Actually, let's dock that out. So this is running here, and if I create that, then immediately you can see the subscription is being raised. Also this, I didn't have to specify which protocol to use to subscribe to the subgraph. Is it GraphQL SSE? Is this GraphQL WS? Or is this the legacy Apollo protocol? Whatever protocol the subgraph uses, the schema composition figures out and configures our gateway, and it just works. So gone are the days where you have this complexity to figure all these technical bits out. Sorry. Okay, let's go over to the slides. Let's talk about query planning, because I said a lot about query planning. And we use something we call PGO, profile-guided optimizations, in the query planning. That means the query plan that you see initially is the one that we can calculate the quickest. And we do that because we don't want to let you wait while we figure out the most efficient way to fetch the data. So we come up with something that is good, but might not be perfect. And then we feed in the telemetry. That is the last component I explained in my initial components that you need for distributed GraphQL. And we're using their open telemetry to collect the data from all the subgraphs, how efficiently we get this data, especially when we are talking about overlapping data that we could get from multiple subgraphs. Sometimes it's more efficient to do multiple hops than a single hop. Or maybe this subgraph is faster in resolving the username than the other subgraph. So we are feeding back the telemetry events that we collect over time, and then we are figuring out if there's a more efficient query plan and feeding that back into the gateway and waiting for feeding that basically to 20% of all the requests. And then figuring out if this new, more optimized query plan is actually faster than the initial query plan. If that is the case, we are phasing out the old query plan slowly and phasing in the new one, and collecting further telemetry information to see that the overall system is stable. And this gives you the best performance that you can get in such a setup. As I said, all is run by open telemetry, and this, like all the tooling that you saw, you can actually dive into these and explore these, and also explore if, like this is the gateway setup. It's just hosted because it's difficult with telemetry data. We continuously have to invoke our demo system to have sufficient data. But you can see here, this is the demo a bit more advanced. We have all these, the beamer is not the best, but you can see these are my clients that are fetching data. This is my GraphQL gateway, and I can see how requests are coming in and how my gateway performs. I can also dive into aspects of other subgraphs, for instance, dive here in the review subgraph and see how these broken down requests, you can see this is the overall request get homepage query, but this is only the 7th part of this query. So when a GraphQL query comes in, we're distributing it across our subgraphs, and this 7th graph of the query performs here like it takes on average 1.6 milliseconds. I could dive into what actually are the most expensive fields here or other aspects, like look at the query plan, look at the query plan variants and how they have performed and things like that. As I said in the beginning, we created Fusion and this open source specification to get rid of the vendor lock that you have. And this is the same for telemetry. This is open telemetry data. You can go with our tooling. You can go with the guild, for instance. You can even use just Elastic, and it will also give you very good results, or Honeycomb, or whatever. And it's all pluggable. Like you can take the tool from this company or from that company, from this open source project, and you can put them all together and get your stack as most performant for your use cases as possible. So this effort is not only backed by the guild and us. There's also AWS behind that effort, IBM, Hasura, and lots of others. AWS, for instance, describes how they use Fusion together with AppSync. You can read into that blog if you're interested. And as I said, it's going under the GraphQL Foundation, which should be, the spec should be available at the, I would say mid-December, should be public. If you want to follow me or talk to me or follow our project, you can pick the URL that you want to have, and I'm open for questions.
Hi, the gateway is orchestrating the subgraphs. So for resilience, if a subgraph isn't responding because of network lag or something else,
yeah,
is the gateway for ensuring the performance, or does it have an infrastructure like service mesh or something else for resilience, performance, and so on?
So the gateway in general, it's an implementation detail to, like, it's not in the spec, it's an implementation detail. But what we do is error rerouting. Like if you have overlapping fields that can fulfill that, we try to figure out a query plan after collecting the telemetry events and seeing, okay, we have a high error rate here. Like in the telemetry solution, you could see that. Like when we discover actually that here you have error rates, like for instance there, we will try to reroute the requests to get the least possible errors in a response. GraphQL is about partial responses. That means like GraphQL always tries to give you at least some data, even if we cannot get some other. So yeah, like in our implementation, yes. That was a question, or was that?
Yeah, thank you, great talk. You mentioned vendor lock-in a couple of times, and
yeah.
There is a standard almost out there. But what you're showing here is your implementation, correct? Eh?
Yeah, but it's an open specification.
Yeah, but this is your implementation. Are there also other implementations already available?
Yeah. Yes, you can also go for mesh. That is from the guild. There is some others also investing in that, like Hasura, AWS. Yes.
Thank you for talk. You showed example for a query, and what about mutations? Is the same?
Yes, I showed also. Yeah, I didn't really say it, but like when we did this subscription here, we also used the mutation, right? If you, yeah, somewhere. I did raise this mutation to cause the subscription to. It was here. Yeah, mutation. We could also, like, okay, in this case, it's a demo, right? I create a review here. It could also be create a product or mutate the product or whatever. But technically, yeah, just a mutation is supported. All the GraphQL features are supported. Defer, stream.
Hi. Are the custom scar type as easy as the standard types to be added in this?
Custom scalars?
Yeah,
or?
scalars.
So in general, they are just supported. In the current implementation that is released, you have to map them in the gateway. But this is going away with version 14 that is coming out like end of December. At the moment, you have to map them. But this is will be automatic.